I would like to show you a little bit what's behind the scenes. All this system with all the different devices and pumps and other bits and pieces needs to have something that controls it and allows you to monitor it. And that is what I'm going to show you now. This is one of several Home Assistant dashboards, and this one is basically the farm status. It shows me at a glance where we are at, if everything is in the green, or where there might be trouble, and also there's a little bit of a weather forecast. So it shows me the current situation. I can see my current power status, which is the state of charge of the battery bank, and also the solar power generation. So right now, the system is producing 6,775 watt, and 1,767 are going into the battery at the moment. Our water tower, which is located in paddock A18, is filled to 88%. That is low, so you see we're already in the yellow there. It needs to fill up a little bit more. And right below it, you can see there's a pump A17, which is running, and I can also see how much power that draws. And further down, there's another pump. That is the Charco A17, which means the pond. That is also running, so that indicates that we are irrigating. So one pump, the one in A17, is filling up the tank, and the other is direct irrigation. The gauges to the right, Zone A status and farmyard status, show soil humidity, but it's the median for each area, or it is the exact measurement from the sensor, depending on what it is. So where it says box, that's the planting box, that is direct measurement, but the others, this is the median of several sensors that are in each location. We do have currently deployed one gate sensor that tells us if the gate is open or shut, and this reports a little bit intermittently because there are some trees in the way of line of sight, and so the signal not always comes through. It's an experiment, and we will improve this incrementally, but it tells us that the gate that controls the easement is shut. Left to the forecast, you can see two boxes that talk about scripts. So there is an irrigation script for the farmyard, for B2, and for the two areas, or the two pieces, let's say it this way, for A11 and A12. That is where Sunham and friends live. And this tells me if they are running. There's a sequence that is being processed. And below that, you can see when these scripts have been active, so that I have an idea if the irrigation on the other day has been running or not. This is now the dashboard for the farmyard that shows me the moisture levels at different locations. Those are the small gauges in the center, the content of the water tower, and also a median of the temperature around the farmyard. And the two water bubble buttons are to turn on the irrigation for several sectors. This is not yet fully automated, so I have to press one of the two buttons to irrigate either the farmyard or B2, but then there is a script behind that will turn on the valves on or off in a sequence. The next step would then be to take the measurement of the soil humidity and based on that turn on the irrigation, given that there's enough power and enough water available. But as power and water is not an unlimited supply available 24/7, for the time being, I, as the human, try to stay in the loop and turn this on based on the context that I can perceive, but the machine cannot just yet. The next piece here is the dashboard for our Zone A, where the Miyawaki forest and also Sunham and friends are located. It is slightly more complicated because there are more sensors. Each sensor represents one of the gauges. I have the median temperature for a group of sensors, so one for A7 and one for A11 and A12. I also show the lowest temperature for a 24-hour cycle. That is important to figure out when something is actually able to germinate. Some plants expect a minimum soil temperature of, say, 18 degrees, and therefore this information is important to see whether plants can actually show up. A7 is not yet automated, so that means we have to go there physically and manually move one of 4 shutdown valves to turn on irrigation per sector. The reason for that is that we don't have network connectivity there just yet. I do have sitting here on my desk a LoRaWAN solenoid valve controller that I need to wire up. I'm also waiting on a second one because these devices only control 2 valves. And once I manage to figure all this out, then we can automate this. But it will not be instant like in other cases, because LoRa does not work like a Wi-Fi network. So you turn something on and then it might take a couple of minutes until the command has been sent and processed and you get feedback that the valve is indeed now open. For A11 and A12 the situation is different. It is much closer to the farmyard and we were able to run an electrical cable over some 300 meters to that place, and because of that we can have a Wi-Fi access point there and a rainboard solenoid valve controller and even 2 cameras. And once again it is semi-automated, so there are 2 water bubble buttons, lines 1 to 4 and lines 5 to 8, and if I press one of them, then the pump will turn on and the valves are being opened in a sequence. Once the sequence is done, I get a message on my phone and the pump in the pond will also turn off in order to avoid any overpressure and bursting lines. The last dashboard that I want to show you is the power distribution, and there you can see the power production, the state of charge of the battery, and you can see more details where power is being consumed. Soon there will be more of these power meters. We have to install them wherever we want to have this. But right now I can see that my water heater consumes 2000 watt. The 2 pumps are consuming 400 and 500 something. And in the Cortijo we have a measly of 56 watt. And that way I can know where my power goes, and in case of a power shortage I can also know what to turn off first. And of course there are some safeguard scripts in the background that will turn off heavy loads like the water heater in case that the battery state of charge goes below a certain threshold. This is a no return valve, and it should avoid that the water tower that is here to our left loses its water to the other tank that we installed. So it only allows the water to flow into the tank but not out of the tank. So we are doing another irrigation experiment here. Of course we can calculate this, but we like to explore the edge to see how much is really possible. So we have 2 lines. That one has 8 wobblers and this one has 7. And it appears that we can use them both. And they seem to throw the water droplets far enough. The idea is that you have as much wobblers running as possible so that you can reduce the time that you need to open the system. And that makes it easier within the same day. Remember, we are running off of solar power to do more than instead of having a little bit of water and then you have to run it for longer. And this is now the highest flow nozzle that we have, and we want to know how far we can get with that. Angel is doing something at the very end because there is some dirt in there, and therefore this is not running as it should because it is open. So if I step a little bit, you can see what's going on. So once the pressure can build up, this should work better. So I'll let you know in a minute. What I can tell you while we wait is, the idea is to turn all this biomass that is currently still standing, also I'm cutting it down step by step, by watering it into soil ahead of time, and maybe allow some other plants to come up due to the irrigation, so that we get more and more roots and therefore more and more biomass into the soil, and over time we can then plant the missing trees here in this area, because this also should have a closed canopy at some point. And then we can remove the wannabe and call it a food forest. So now we are doing a second part of the experiment. They seem to wobble well over there, but they are closer to the inlet. And Angel is now cutting off the second line so that we are left with 7 wobblers, to see how much this one will throw the water droplets. And I hope that I can show you that while I maintain position here. So there was a drastic change, including the sound. And now I get a few drops here where I'm standing. So here in front of my feet I see a little bit of water, but it also goes all the way to there. There between the leaves of the tree you might see some water droplets. So this is how this thing can operate, given that there is enough water pressure and flow, because 8 plus 7 is a bit too much. And now I would love to have the table ready, but I don't, because each one has a spec, and there it says how much liters per hour it lets through. And basically based on that we can calculate how many we should operate at the maximum. But like I said, the idea was to figure out the edge, because longer lines mean less time, and less time means less power required, as we have to irrigate during the day. That is important. And also bigger droplets help to reduce evaporation. The alternative is to irrigate at night, so that consumes water, but then requires bigger batteries. And bigger batteries is quite expensive. And you can only optimate for one of the 3 factors. So droplet size, the amount of water, and the amount of electricity that you want to use. And you can calculate these things ahead of time, or you can try to find the edge, how much in a given situation can actually work. But calculating is also a bit complicated, because the diameter of the feeder line is also another factor. But we are now using 1 inch, and that is what our valves are made for. And so we are trying to do everything with that, except the lines between the wobblers. But even there we can change from 25 mil to 32 mil, and that's the outside diameter, so the inside is less than that. So with 32 outside we get 1 inch on the inside, and if the connection between the wobblers were 1 inch, then we would lose less pressure. We tried this in another place, and it works very good there. So it's a learning process. I don't think that this is really working, because the stuff is so dry and does not fall over as it should, and I think we have to take care of this in a different way.